Alright, so let's get working on hiding. The main point of hiding is a way to escape from our future AI's wrath. You could create this method where the character hides manually, as in they open the locker door, walk in, and have to close it again. But we're going to create an automatic version where they walk in and close the door after just interacting with it. As you could easily do the first version with only the logic from when we created these doors, but we want to make ours a little more automated. Alright, so I made a quick locker in Blender, so we have something to hide in. We can import it for this project. It's something you're going to want to replace for your own project, but you can use it for these tutorials. So let's go ahead and import that. So let's open up props and meshes. We're going to import it right here. And once you've navigated to where you've downloaded our two FBX files right here, we have a locker and a locker's door. They're separate objects because we need to be able to open the door. So let's hit open. And they will not be a skeletal mesh. Auto-generate collision is fine for now. Everything else looks good. So let's hit import and import again. Or you can just hit import all if you want all the settings to be the same. It's going to create two materials for us. We only need one material because we're going to put the same one on both. So I'm just going to delete material 02, force delete, and let's open material 01. And I just want to make this look a bit more like a locker. So we're going to make it blue and we're going to make it a little shinier. So let's just take this color here. Let's make it a nice dark blue, maybe something like that. And we want to up this metallic input right here, so we're going to use a constant. So if you hold down 1 and click, or right click and type in constant, it gives us a value, which is just a float, and we're going to make it 0.8 because it is a value between 0 and 1. Plug that into the metallic, and it's a bit shinier now, looks a bit more like it's made of metal. You can mess around with it more. It doesn't matter too much, as you should be replacing this with your own object of whatever you want your player to be able to hide in. But maybe we could even take this roughness and not 0, but 0.4. I don't know, I'm just kind of experimenting right now. It looks good, so let's hit save. And back in here, it applied it to our locker door. We need to assign it to our locker as well. See how it looks on the door. Yeah, that looks fine. And on the locker, let's change the material to, oh, we didn't name it. So let's go back and rename material 001 to matte, or I think it's M, that's how I do it, locker. Open up the locker again, and we will assign this M locker. All right, that looks fine. And in locker door, we could put it for the second material right here if we want. Or we can make that some kind of separate, let's see, let's bring this material out of the meshes folder and into the materials folder. So if we click this icon right here, it kind of shows us this layout, and here we have our props and we're inside meshes. We want this inside materials, so I'm just going to drag it, move here, and now it's in our materials. I'm just going to take this battery texture and I'm actually just going to use it on this little front part here, just to, so we don't have to make another. Actually, I honestly hate the look of that, but it's fine as this is just a tutorial. Yeah, I'm going to change it to M metal instead. Definitely spending too much time on trying to make this locker look good, even though it's just for teaching you how to do this, but we're all done now. I'm going to collapse this again because I like it closed. And we're ready to get started. So let's go to our blueprints, and we're going to need to create a blueprints for actors we can hide in. So blueprints actors, and we need a new category, a new folder. And so right click, new folder, and we'll call this hide actors. And we're going to use the same method of creating a parent class and children so that you can create many different types of places where your character can hide. So let's open this, and let's make an actor. Right click, blueprint, class, actor, and we will call it BP hide actor. We can open it up, and I'm just going to close all these meshes right here. And we need a few things. We need a static mesh. This will be just the mesh that we're hiding inside. And we also need 2 arrows. And I'm going to call this arrow player position. And this arrow exit position. Now we don't want this arrow as a child of player position, so just drag it on top. So none of them's apparent. And these arrows will decide the place that we want to move our character to when they hide, and then when they exit hiding, since it'll all be automated and you don't walk in yourself. Once again, you can have it like that, but you would just need to follow the door tutorial, as that's all you would need, as long as you have a mesh that you can walk into and out of. So let's make a child actor of BP Hide Actor. So let's right click on BP Hide Actor, create child blueprint class, and instead of child, we'll call this locker. BP Hide Actor locker. Let's open that up. Now this static mesh right here is going to be our locker. So you can search for locker. There we go. And we also need a door on our locker. So in this one specifically, we're going to add a second static mesh. And we're just going to make it a child of the inherited static mesh from our parent class right here. And this will be the door. So search for locker again, and we'll just do locker door. Now we need to reposition this locker door so it's actually at the right spot. I've already done the math of what location that needs to be at, so you can just copy these values. If you made the mesh yourself, then you should already know the values, and if you buy a mesh, then you're just going to have to fiddle around with it until it looks good. But for this one, we have negative 37.5. Oops, I put 2. Negative 37.5. There we go. On the Y, 39, and Z is 0. Now we also need to reposition these arrows. We need to put them where we want our player to be hiding and where we want our player to exit once they leave the locker. In terms of verticality on the arrows, we need to put the arrows at the same half height as our player capsule if you want your player not to move up or down. So let's go to content and game PP level 1 L1 character, and right here under capsule component we have capsule half height, and this is just half of the length of this capsule right here. So see this blue arrow, we need those other 2 arrows to be at the same Z axis as this blue arrow, or when your player moves he'll move up or down, and we just kind of want him to go straight into it. So our player half height is 88, so we can take our player position, make the Z value 88, and we'll do the same thing with the exit position. So now let's reposition these. So for the exit position, I'm just going to pull this out for a minute, and for this door I am just going to hide it real quick. So just visible, just turn that off for a second just so I can see this. It's already dead center inside the locker, so I'm going to leave it like that, and I'm just going to rotate it 90 degrees so it tells us which way we should be facing. And I want to be facing, I'm going to make this visible again, we want to be facing towards the door so we can kind of peek out of these things right here. For the exit position, when we come out, I also want us to be facing this way, so I'll rotate this 90 degrees. And a good length I found is making it the y-axis 200 when they come out. That's a value I like. This will obviously be something that you just adjust based on what you feel you need. Now, so we need to be able to interact with this locker so that we can enter and exit it. And it's been a while since we used it, but we still have our BPI interact, or our blueprint interface, and we can just add that to anything we want to be able to interact with. So if we go to our class settings right here, implemented interface. Oh, we're doing this in the parent class, by the way, so every child class will have the same interface. We want to add BPI interaction. And now, if you remember, in our L1 character, which I'm just going to compile real quick, in our event graph, when we hit, I'll have to find it, we should probably organize this a bit. When we input action, we're checking to see if we hit something with the BPI interaction interface, and if we do, it calls the interact event. So now that it's been implemented into our actor, we can now call this event. So let's do that. Let's go to the event graph. Here in interact, just right click and implement function. And we need a reference to our player character. So let's get that in the begin play. I'm just going to delete those two, bring this up a bit. So in the begin play, let's cast to L1 character. Object, as always, is get player character. And let's make this a variable. Player ref, as always. So when we interact with it, we want to move the character into our hiding spot. No matter what our child hide actors are, no matter what kind of hiding place they are, in every single one, we do want to move to this player position. In the locker itself, we're going to add some code to make sure the door opens first, and then we go in, and then the door closes. But that won't be universal to every single hide actor you might make. So in the hide actor itself, we'll add the moving, and then in the children, we'll add any extra necessary steps we need. So let's make a custom event, and we will call this move character. And we'll just pull this, and basically we have to do exactly what it says and just move our character. So we'll get our player ref, and we will set the actor transform. And it's this one right at the bottom, set actor transform. And our transform holds our location, rotation, and scale, even though we will only be messing with the first two. So let's split this. So we have our location, our rotation, and our scale. So we want to set the location by interpolating our character from its current location to the inside of the locker. And we can do this with a v-interp, which is a vector interpolation. So we can search v-interp, and we want a v-interp to constant. A v-interp to constant will reach this target at a constant rate, while a v-interp to, the regular one, gives it a smooth feeling when tracking. But I feel like this actually doesn't work as well when doing kind of a hiding function, because it's supposed to feel like it's being done in a haste. So when you kind of ease into it and then ease out when you get into the locker, it feels a little too nonchalant for me, and the constant feels a lot more rushed and hurried, which is why I like the constant. So for the current location, this is just our player rest location, so we can get actor location. And the target is our player position. So we can drag this out, and we will get world location. And this goes into our target. And the interp speed, or how fast it goes, we're going to set this to 1000, which is a pretty hasty speed. Lastly, for delta time, we need to just get the world delta seconds. Now, a interp node needs to be called every frame for it to run smoothly. You can't just call this once, or it'll move you for one frame and then stop. And we'll do this with a timer. So when we interact with our object, we want to start calling this move character every frame. So first thing we want to do is take our player ref and actually set its collision to false. This way it doesn't get stuck on our locker, and that could create a lot of bugs. So technically when it's inside the locker, our player doesn't have any collision. So we want to set actor collision, enable collision, and we want to set it to leave it as false. So it turns off our collision. And then let's just call our move character timer by event. So, or set the timer by event, sorry. So set timer by, now we've usually done set timer by function name, which you could use, but in this case, we're just going to set timer by event, because sometimes when you're using an event, it's just a little cleaner just to plug in this event to there, and now it knows what timer to set. I should mention though that set timer by function name also works if you type in the event into the function name. So if I were to type in move character right here and plug it in like that, this would also work. But we're just going to do it like this. So the time, we want it to be every frame. So we will get the world delta seconds. And looping is true. Now we can actually test this out now to see if it works. So let's go ahead and come in here. The map's getting a little crowded here, so how about we take this, I'm going to hold down Alt and drag, that duplicates it and drags out a new one. Change this to unlit so we can kind of see what we're working with. I'm just going to drag it out like that, and drag this out. We're just creating this big old hallway. And then take these three. I'm going to hold Alt, drag, and we're just expanding our room to add more things. All right, now let's change this back to lit. So it's going to be a little dark back here when we build the lighting. So I'll hold Alt with these lights again, bring them over here. And let's just build lighting only, so this doesn't kind of have this weird gray line going on. All right, so let's add our locker in to this scene. So blueprints, actors, hide actors, and we have our locker. Let's kind of put it in the light over here. And what should happen now when we interact with it is our player will lose collision. We won't really see that happening, except that it'll go through the door, and we should just move right into the middle of the locker. So let's hit E, and there we go. We've moved into the locker. You can kind of see out. We can't really move anymore, and we're kind of stuck in here forever. And it's constantly calling this move character event, but it's definitely a great start. So let's start with the most obvious thing, is that the door doesn't open or close. We just phase right through it. Second, as I just mentioned, our timer is still firing every tick when we're inside, so it's always updating us to force us into that position right in there. So let's kill the timer once we're inside. So let's go to BP hide actor, and after we set the actor transform, which we're doing every frame, we just want to check to see if our player location is at this new arrow position. So we'll get a branch, and we just have to get our player reference, get actor location, and then our player position, and get world location. And we just have to make sure that this player ref's location is at this world location. So we'll get an equals equals, and we have this equal and equal exactly. We want the equal because equal exactly is risky to use, and if it doesn't get perfectly spot on by 0.00001, it won't work. So let's get this equal, and we can change the tolerance. So this is how close it has to be to this vector right here, and I'll actually just change this to something like 0.01. So we'll still always be in the same position, but it will always make sure that we did make it. So let's plug that into the branch, and if it's true, we want to clear this timer. And we do this with this return value here. So if we pull this off and type in clear and invalidate timer by handle, this is the node we use to stop this timer when it's set timer by event. So let's break this execution because we obviously don't want to do it right after we set the timer. You only want to do it once we've reached our location. All right, compile and save. So now let's print a string to say moving character to show us that we've stopped. So let's go to the locker and let's hit E and I'll say moving character, and it should go away now that we're inside. No longer calling that tick, no longer using up unnecessary space. So we want to do more than just disable the collision. We want to disable our movement as well. We don't want to be able to quote unquote walk around the locker, especially because it's no longer moving our character. And I should have demonstrated that, so let me actually do that now. Here, I'm gonna move our player, since we're gonna be working with this a while, I'm just gonna move our player start right here, make us face the locker. Let's play again, and let's go to our locker, hit E, and now if I kind of try to walk around, we're still pretty stuck, but in my testing I could see that it could create bugs, things could get kind of jittery. Right now it seems to be fine and doesn't seem to have any big issues, but just for safety's sake, let's disable our movement when we're inside this locker. So in BP Hide Actor, before we set the timer, when we turn off the collision, we also want to disable our movement. So let's get our player ref, and we'll need to get our character movement from here because that handles all our movement, and we will disable movement. And now it won't look any different, but our movement doesn't register when we're inside the locker. All right, last thing to do in the hide actor for now is adding a way to get back out of the locker, because we get in, but now we can't get out. So we need to create a Boolean in our character, actually, for if we are hiding. So let's create this. We'll call it is hiding, because I want this to be known in our character and not in our hide actor. So let's go back to our hide actor, and now we can kind of do a flip-flop between hiding in the locker and getting out of it. So we're going to pull this out, and we're going to create a branch. And we just need to ask if our player is hiding. This is the new Boolean we just created. If we are not hiding and we interact with it, we want to follow this logic. So we're going to move this to the false node. I'm just going to pull it all down since we need to add stuff to the true. You as well. All right. But if we are hiding and we interact to get out of the locker, we actually want to set timer by event. And we're going to use this same move character event. And we're just going to change things up a bit in here to decide whether to move us in or move us out of the locker. It saves us from creating two separate events since they would be mostly identical for the most part. So it will set the timer for the same event. The time will be world delta seconds, and it is looping. And at the end, when we finish moving, we want to clear and invalidate this timer as well. So we'll get this, clear and invalidate timer by handle. We don't want to do it right after we set the timer, so we're going to break that. And we're just going to pull this back here, and it's going to invalidate both, even though it'll only ever be using one. It'll just invalidate both, just so we don't have to create unnecessary if statements to decide which to invalidate. Now this still is technically invalidating moving out of the locker once it moves to the interior player position, but we'll fix all this up so it knows which to move to. So let's actually do that. So the first thing it does is set the actor transform by V interpolating it to our player position. We need to decide if it's moving to the player position or the exit position. And we can do this with a simple select node. So we're going to get the world location of one of these with a select node. And the wildcard, or the index I should say, is our player ref is hiding. So just get our player ref, ask if they're hiding. If they are hiding, we want to go to our exit position because we're leaving. And if they aren't hiding, we want to go to the interior position. So they start hiding. We'll do the same thing over here because we have to ask whether we've reached our player position or our exit position. So same thing, get a select node. I'm going to copy and paste the player ref is hiding. And if we are hiding, we want to ask if we're going to the exit position. And if we're not, the player position. And I want to reiterate, player position is just the hiding position. We should probably rename it to that so we don't get confused, because it's not the current player position. We'll call it hiding position from now on. So now, no matter which one we're doing, when we finish, both timers are invalidated, even though one won't be going off. So I think we can actually test that right now. Hitting E on it, we've gone inside. If we hit E again, we do not move outside. So I must have missed something. Let me figure out what that is. Oh, of course, the reason this doesn't work is because we never actually changed this boolean is hiding. It's false by default, and we never change it to true, so it doesn't know to switch to the next part. So we can do that by creating a custom event, and we'll call it finished moving. So this will be called once we've finished moving. And we just need to ask if we're hiding. And if hiding was true, we need to set it to false. And if it was false, we need to set it to true. So check it for this one. We're also doing this in the finished moving custom event because I don't want us to be officially hiding or out of hiding until we are fully in or out of the locker, instead of right when we interact with it. This can be useful for when we implement AI, so that if an AI is chasing us, for example, and they can see us, say they're right there, they see us when we click going into the locker, since it'll automatically change to is hiding even before I'm inside the locker, that can mess up some of our AI logic because they now think we are hiding when we should still be in plain view. That's why we're doing it after it's set to finish moving. Once we've stopped hiding, so we set is hiding to false, we also want to re-enable the collision and re-enable the movement, obviously, so we can move around again. So let's just get another player ref right here. And let's set actor enable collision. And we want this to be true. And then we can get our character movement. And if you remember, I mentioned this in a previous episode, there is no just enable movement node. We need to set the movement mode to walking, which is the one we use at all times. It's also the default movement mode in character movement. So after we clear and invalidate these timers, we're going to call finished moving, and we can test this out. Now we can see if it works and let us go back and forth. So we're going in, we are now in, finished moving has been called, we no longer have collision and we cannot move around. We hit E again and we've been moved outside the locker, and enable collision has been re-enabled, and we can walk around. So we can just go in and out, back and forth. So now that our hide actor works the way we want it to, we need to adjust the locker itself so that it opens and closes the door accordingly. And we're going to need to create an event dispatcher in our regular hide actor, so that we can reference it in our locker. So let's create an event dispatcher, and we're going to call this finished moving ed for event dispatcher. And after we finish moving, we're going to call it, or right before we do everything else. So just drag it out and then hit call. And I believe I've explained event dispatchers in a previous episode, but essentially they work similar to interfaces where this is called and we can assign it in other blueprints, and every time this is called, it will trigger in the other blueprint. So in our BP hide actor locker, we need to create a, in the interfaces, we need to implement the interact function. Now let's right click on it and add call to parent function. Now the way this works is when we interact with the locker specifically, we have this parent interact, and everything inside this parent interact node is everything we have in the parent after interact is called. So all of this is in this little node right here. Now by default, when you don't have these two separate, it does this all by default immediately. But now that we've created it separately, we can choose to do things first and then call this, such as open the door and then move our character. Now if you see, we don't connect these at all because we created them separately. If we try to interact with our locker, nothing happens because this parent interact is never called. If we plug it in, once we interact with the locker specifically, the parent interact will be called and we can move in and out. So let's break this again, because before we call the parent, we need to open the door. And we'll do this with a timeline the same way we open all these doors over here. So let's create a timeline, and we'll call this open locker door. Open it up. The length is the amount of time it'll take for the door to open. I'm going to say 2.25, so a fourth of a second. And we need to create a float track, and we'll call this float track alpha. And this is just a 0 to 1 graph we'll make. So let's just add the two keys. Time 1 will be 0 and value will be 0. Time, we want this to be at the end of the length, 0.25, and a value of 1. So it takes a time of 0.25 seconds to go from a value of 0 to 1. And we can select both of them, right click and change this to auto for a bit of a smoother opening. If you remember me talking about the vinterp2 and the vinterp2 constant, this is a good visual difference. This is the vinterp2 where it kind of smooths in and out, but if we were to change this to linear, this is the constant. It goes at a steady pace the entire time. But for a door opening, it almost always looks better when you've got this smoothing. So back in the event graph, we have now our updated timeline, and we just need to use this alpha to open and close this locker door, which is our static mesh 1. This one right here. So I'm just going to move this parent interact over here, because we'll come back to it later. And we can get our static mesh 1, which is our locker door, set relative rotation. Now we've done this a few times since we made 3 different types of doors. I want to plug it into the update. And the new rotation, we only want to rotate on the Z axis. So you see, that's how we open it. So let's split this. We have the Z right here. We'll use a lerp, which is a linear interpolate. And the alpha will go into the alpha. So this A float right here is equal to 0, and this B is equal to 1. So it will follow this graph right here from 0 to 1. And our door being closed is at 0, and then when it's open, we want it to be at 90. So let's plug that into B, 90. So now we can actually even show you how this works, our parent interact is never called. So when we interact with the locker specifically, it just opens the door. That's all it'll do. So once this timeline is finished, we can then call our parent interact. So it'll wait for this timeline to be done, it'll wait for the locker to open, and then we will go inside. So we can test that out again. We can watch, open, then we go inside. And that looks a lot better so far. And if you want, you can add a small delay after the timeline to give it a bit more of a natural feel. So we don't go in literally the same frame that the door finishes opening. So maybe like 0.1 seconds. And you can try it again. And there's just that tiny little delay before we go in. I think it makes it look more natural, more human. So now we need to be able to close the door once we go in. So let's create a custom event. And we'll call this close door. And right before we continue, I just remembered we want this to play from start instead of just play. And this will just ensure if all these are play from start, it will all go smoothly and it won't ever get stuck in the middle somewhere, because we're going to need a second timeline for closing the door. So we're going to copy this and paste it, play from start, and we can just call this close locker door. But we don't need to change anything on the inside because we want it to be the same length, unless you want it to be slower or faster for some reason. And we just need to copy all of this. So we're setting the rotation, alpha, and we just need the A to be 90 and the B to be 0. That way, instead of opening, it closes. Now we need to know when to call this closed door. We don't want to close the door until we're fully inside the locker. But depending on how far away or close to the locker we are when we interact with it, can alter the time it takes for us to get inside the locker. That's the main difference between timelines and interpolation. Timelines will always take the same amount of time to do the same thing, while interpolations is interpolating from one spot to another, which can change how long it takes depending on the distance between those two things. Which is why we've created this event dispatcher. We have this finished moving custom event which is called once we've finished moving. So it's perfect to use this event to know when to close the door. So we created this event dispatcher, and now we need to call it in the locker. So every time this dispatcher is fired, we can close the door. Or we can close the door when we go into the locker every time this is called. So in the event begin play, just gonna delete these two right there because we don't use them. Oh, didn't mean to do that. Let's just bring these up. After we parent to the begin play, I can't remember if we actually have anything in our begin play. We do, we set our player ref. So we want to keep this parent right here. I'd keep it anyway just to be safe, but it's good that we know. And we just need to assign this event dispatcher. So we can search for finished moving, but we don't want this finished moving function. That's the event that we made. We want the finished moving ED, event dispatcher. And we have all these different options. And what we want to do is assign it. This creates both a node and an event. And we can call this event. Yeah, we could just leave it as that, or let's take out that 0, but we can just call it finished moving ED event. So every time that this finished moving event dispatcher is fired, which is called every time we finish moving, this custom event will be called in our locker. And that's why event dispatchers are powerful. So after we finish moving, we just want to close the door. So we can call this event we just made close door. Caps lock is on. But once again, if we want that more natural feel, I'm going to give it a small delay of 0.1 seconds. So it doesn't happen the same frame that we finish moving. So let's see how that looks. So it's open, it closes when we get inside. Perfect. And it closes when we come back out as well. Look at that. We can now hide in a locker. Now let's fix this small bug that you might not have noticed, but it kind of happens if you start like spamming your action button. So if as you can see, we don't want this. We don't want this happening. That's pretty ugly. So we only want to be able to interact with it when we're not in the process of moving in or out. So we need to disable our ability to interact with the locker specifically when we're running through all this code. So we'll create a Boolean for this, and we'll just call this can interact, and we want to set it to true by default, because we want to be able to interact with it by default. And in our locker, when we interact with it, event interact, we first want to check if we can interact with it. So let's just get our can interact Boolean. Once again, if you don't see these variables on the side here, you need to check show inherited variables right there. So if can interact is true, then we can continue. If it's false, we don't do anything. But if it's true, we also want to set can interact to false immediately. So it continues. We can't interact with it until we finish, which I want to be after the door closes. So after close locker door is finished, set can interact back to true. So this no longer gives us the ability to interact with our locker while we're moving inside or outside of it. So now if we spam the action button, it just plays out the way we want this to. Perfect. There's one more bug to address. When we open and close our inventory, when we're inside the locker here, I'll show you, a lot of parameters get reset. If you remember, right now we've just disabled our collision and our movement, but opening our inventory also disables our movement. But then when we close our inventory again, it re-enables our movement, and that can screw things up. So if I show you, if I open my inventory and close it again, actually, we've gotten pretty lucky, nothing's happened, but kind of like the last issue, when our movement is actually technically now enabled, and that can create bugs, things can get jittery. I've definitely fallen through the floor at least one time while trying to test this out, and we don't want any of that happening. So we will go into our GameBP HG player controller, because this is where we open and close the inventory. Toggle inventory, and we want one more if statement, create a branch, and let's promote this condition to a variable, and we will call this can open inventory. If we compile, it's we want the default to be set to true. We want to be able to set it, and we only want to be able to open the inventory if it's true. Now if we go to our hide actor, our master class, in the begin play, we can cast to HG player controller, object is player controller, get player controller, and we can just promote this to a variable. We'll call it controller ref, and we just need to set when we can open and not open our inventory. So we don't want to be able to open it once we're entering our hidden object. So if we're hiding, if it's false and we're going in, we set our actor enable collision to false, we disable the movement, and then we get our player controller, and we set the can open inventory to false. Now we need to reset this back to true once we're out. So we do this at finished moving custom event, and at the very end, after we've re-enabled our collision and movement mode, we set can open inventory back to true. And now if we press play and we go into our locker, we can no longer open our inventory unless we leave. All right. Well, that's everything about how to create a hide actor. We've designed it in a way where you could easily make more, and just remember the rules about when to call this parent interact when you interact with the children. Some things won't need anything. Some, if you're like hiding under a desk or something, you can just call the parent interact, and that'll be that. But yeah, everything works well, and we can now have a place to hide from our AI that does not exist yet.